Here's the answer to question 1F. So we have been given some information here, and we're told we've got a sample of babies, and we've got this graph down below. So we want to, first of all, does the data follow an approximate normal distribution? Okay, and we're told we should consider shape, centre and spread of the distribution. So the first thing I'm going to do is I'm going to draw my graph over the top of that. All right, badly drawn, but that's okay. Does that look approximately, what shape would that look like? Okay, and I would say it's not a great normal, but it is approximately normal. It's not particularly skewed one way or the other. Then we need to think about, well, where is the centre? Okay, so in terms of our centre, I look at, well, where would the middle be? Where would the mean be? And that mean, I would say, is probably somewhere around about 3,000. Okay, then what else do I need? I need to talk about the spread. Okay, so in terms of the spread, now I'm just going to jump over here for a moment. When we have a standard normal distribution, our Z distribution, excuse me, what we do is we talk about how we've got our mean in the middle. And so say I had a mean of, like we did originally, of 3,425 with a standard deviation of 550. So I take that mean, 3,425. I'm going to go, if I add and subtract one standard deviation, so if I do the mean plus one standard deviation and the mean minus one standard deviation. So I go one standard deviation away. That's going to be 3,425 plus 550 and 3,425 minus 550. And that gives us 3,975 grams and 2,875 grams. So that means if I go up by 550, down by 550, that takes me to that place there, which is that is 2,875, and this point here is at 3,975. Now I know, and this is one of the theoretical pieces of knowledge I have, is the area between that. If I go plus or minus one standard deviation, then that area there is approximately 68%. Okay, so about 68% of the data is within one standard deviation of the mean. Now I want to go 2 standard deviations away from the mean. So I want to go the mean plus 2 standard deviations and the mean, plus 2 standard deviations and the mean minus 2 standard deviations. So I want to go down another standard deviation, so I want to take away another 550 and I want to add on another 550, and I want to get to the 2 new values. Okay, so that will give me 4,525 and 2,325. Okay, so now if I go plus or minus that, so I've gone down, that takes me down to 2,325 and 4,525. So this area that I've now worked out, this space here, I'm going mean plus or minus 2 standard deviations, all of that. Okay, that whole area is approximately 95%. Okay. Now what I need to do is I'm going to do one more. So I'm going to do plus or minus 3 standard deviations. Okay, so I'm going to do the mean plus 3 standard deviations. So I'm going to go up another 550. And I'm going to do mean minus 3 standard deviations. So I'm going to go down another 550. Okay, and when I work those out, I will get 5,075 and 1,795. So that now gives me there 1,795 grams up to 5,075 grams. And if I shade in all of the area between those 2 points, so plus or minus 3 standard deviations, all of that space, that whole area there is approximately 99%. So about 99% of the data lies within 3 standard deviations of the mean. Now that's the piece of information I'm going to use to work out my standard deviation for the graph. Okay, so what it means is that if I go from my smallest value to my largest value, that distance there, I'm going to say that is approximately 6 standard deviations. So from the mean, I'm going to go up by 3 standard deviations, down by 3 standard deviations. So the total distance is 6 standard deviations wide. So to find my spread, I'm going to take the maximum is 5,000 minus the minimum is 500, and I'm going to divide that by 6. So that means I've got 4,500 divided by 6, and that is 750. So that tells me I've got my standard deviation for the data is about 750. So that's the first thing I want to do. Shape center spreaders. I want to write that as a sentence. Okay. So I'm going to say the sample is approximately normally distributed in shape and remember, achieved is stating it, merit is justifying it. So how do we know? What is it about the shape that tells us that? Well, it looks like it's quite symmetrical. There's one peak in the middle and the tails are of similar size. So that's what I want to say, because the graph is reasonably symmetrical. Has one peak and the tails are similar in size. Okay, then I want to talk about the center. Okay, so that was my shape. Now I want to talk about the center. So the center, the mean weight of my sample, so the mean weight of babies in the sample is approximately 3,000 grams. Okay, then I want to write a sentence for the spread. Oh, I should justify that. Why is the centre about that? No, not for this particular one, actually. I don't need to, just because that's where the middle is. So in terms of the spread, I can say the standard deviation for the sample is around 750 grams. Okay, so let me just go back to the question. So the question says, does the data follow an approximate normal distribution? Yes, it does. Okay, and so that's what a sentence I just want to add on the end here. This is approximately a normal distribution. Okay, next one. Compare this data to the normal distribution given in part A. Okay, so in part A, and that's why I've got the bit at the top here, in part A we were told that that newborn babies have a mean weight of 3,425 and a standard deviation of 550. So we want to now compare ours. So we've got the data from part A is normal with a mean of 3,425 and a standard deviation of 550 versus the new data the sample, okay, that has approximately normal in shape with a mean of 3,000 and a standard deviation of 750. So we need to compare these. So when we're doing it, we're comparing the shape, the centre, and the spread. So comparing the shape, both the data sets are approximately normal in shape. Okay, centre. When we want to compare centre, we want to see which one is bigger and by how much. So let's think about which one's bigger. So the original one, mean of 3,425. The one from our sample, about 3,000. Which one is bigger? Well, the original one is. And how much bigger is it? It's bigger by 425 grams. So that's what we want to say there, is that the mean in the original data is larger. I should say the mean weight of babies in the original data is larger than the sample by 425 grams. Justify that because the mean in part A is 3,425 grams and the sample mean is 3,000 grams. Okay, shape, centre, spread. So I need to compare the spreads. So the first one has a spread of 550 and our sample has a spread of 750. So because this one is got a bigger number, that means that data is more spread out. Okay, and that's what we want to say there. So we want to say the data, no, I shouldn't say the data, the weights of babies, do it in context, the weight of babies in part A has a smaller spread than the weights from our sample. Now I need the evidence because the standard deviation is 550 from part A and the sample standard deviation is 750 grams. Okay, and there is our answer. So we need to look at marking this. All right, so if you are able to go and find for me this information here, shape, centre, spread. All right, so if you're able to do that and write it up in the sentence, which is this one here, so write me up 2 of those 3 sentences, then that gets you the achieved. All right. If you are then able to go on and make a comparison, so then you are able to, for example, compare the shape and centre, so compare 2 of those, that gets you the merit. You need the justification, no. Okay, I need that evidence and I need to know how much bigger it is. And then able to compare the spread, that gets you through to the excellence.